Good morning, everyone. My name is Sujan, and I am pursuing MC at Chanakya University. Today, I am presenting my project on heart disease prediction using machine learning and explainable AI. In this project, I build a model that can predict heart disease and also explain the result in a way doctors can understand. Let me briefly explain what I will cover in this presentation. First, I will introduce the problem and why it is important. Then I will explain the dataset and pre-processing steps. Next, I will talk about the model used. After that, I will show the result. Finally, I will explain how explainable AI helps in understanding the model. Heart disease is the leading cause of death worldwide, causing around 70.9 million deaths every year. Traditional diagnosis methods require expert doctors and sometimes expensive tests, which may not be available everywhere. So the goal of this project is to use machine learning to predict heart disease early using simple patient data. Also, I focused on making the model explainable so that doctors can trust the result. For this project, I used the UCI Clever Heart Disease dataset. It contains 303 patient record and 14 important medical features such as age, chest pain, blood pressure, and cholesterol. The target variable has two classes. 0 means no heart disease and 1 means presence of heart disease. This dataset is widely used for research in medical machine learning. Now I will explain how the data was processed. First I loaded the dataset, then I performed exploratory data analysis to understand the data. Next I handled missing values by replacing them with the mean. After that I separated features and target variables. Then I split the data into training and testing sets in an 80 is to 20 ratio. Finally, I applied standard scaler to normalize the data. These steps help improve model performance. For prediction, I used logistic regression. This is a simple and effective algorithm for binary classification problem. I choose this model because it is easy to interpret, it provides probability outputs, it works well for medical datasets. Also, it supports explainable AI, which is important for this project. Now let's look at the result. The model achieved an accuracy of 85%, precision is 84%, recall is 86%, and F1 score is 85%. This shows that the model performs well and gives balanced prediction. Next, when comparing different models, logistic regression performed the best with 85% accuracy. Other models like decision tree, Navy Base, KNN, and SVM had slightly lower performance compared to the logistic regression. Now I am coming to explainable AI. The model shows that features like number of blocked vessels and ST depression are the most important. These results match real medical knowledge which increases trust in the model. Some key findings from the project are logistic regression gave the best result, feature scaling improved performance, important features match clinical knowledge, and it also have some limitations. The data set is small, it is taken from a single source, no external validation was done. These can be improved in a future work. To conclude, I successfully developed a machine learning model for heart disease prediction with about 85% accuracy. The use of explainable AI makes the model more transparent and useful for real-world applications. In the future, this can be improved using advanced models, deep learning, and real-life applications like mobile or web apps. Thank you for listening.